All right, so you guys know that the sun is the center of the solar system, right? That's old news, but have people always known that?
No.
Absolutely not. Okay? Here's the problem. People didn't always have electricity. We didn't always have these bright lights on all day, all night. And basically, it would get dark outside, and it would just be dark. It would be very expensive to have a candle or something else to have light, especially when you go way back in time. And so people really just, all they could see were the stars. If the moon was very bright, you could see then, but some nights all you could see is the stars. Everything else was black, so what are you going to look at? You're just going to look at the stars a lot. And the stars in general pretty much look the same. These are the stars, they're not changing very much, except there's a problem. There are these things. Look, this bright star is here, but then a couple days later it's here. A couple days later, a couple days later, a couple days later. Where would you expect it to be next? Here? Except it wouldn't. It would stop. Uh-oh, now a couple days later it's here. What's happening here? It's going which way? Now it's going backwards. It stopped again. A couple days later. So over the period of, let's say, a month or two, there were these random stars, these weird things in the sky that instead of, well, a star that moves would be unusual anyway, but instead of just moving in a regular pattern, they'd actually make this zigzag across the sky. And people were seeing these for hundreds and hundreds and hundreds of years, and it was weird. It was something to watch, because all you were looking at is the stars for large amounts of every day. You would notice that. You'd say, wow, look at that star zigzag across the sky. That's weird. Now, this particular example I gave you here, they named Mars, which at the time meant god of war. Because this must mean something significant. This must be like a big deal. Okay? And this was just, there's the god of war. It does a little zigzag every now and then across the sky. Maybe it means something, maybe it doesn't. And so one of the first scientists, Ptolemy, he came up with a model to predict how that star would move. Okay? It's a complicated model. I'll describe it briefly to you. But Ptolemy's model, what it did well is that it accurately predicted the motion of the heavenly bodies. The different spots in the sky, it would predict it. And that means okay, I've got this model. I can predict in 1 year where Mars is going to be. 1 year from now, Mars will have gone here, stopped, come back. Mars will be exactly there. And his model was pretty close. In 5 years, it'll be there in the sky. They'd make these predictions. They'd measure how far off they were. They were never perfect, but they were pretty close. Okay? But, now, if you laugh, well, you already know this. Earth was the center of his model. And you already knew that, right? That people used to think Earth was the center of the universe. So Earth was the center. And this model was accepted for 1,300 years. So it's accepted for 1,300 years because it was the best model that they had. Here's how it worked. Okay. Here's kind of a nice drawing of it. Here's the big solid Earth that we're all standing on. Nice center. Here's the moon. The moon is clearly the closest to it. It's huge. The moon is the most important. It's big. But the sun's pretty important too. That's further away. Venus is the next. Venus between the moon and the sun. Mars is outside of the sun there. And outside of the sun, you have this sphere of stars. And the sphere of stars is circling around us too. The stars are on this like ball that's spinning around us. It's like we're inside of a giant soccer ball with stars on the inside, and it's spinning about the same speed as the sun is spinning. This was his model. Now, his model also accounted for this. Also accounted for the zigzag across the sky. And it did it with these extra little circles here. Okay? So it wasn't just a circle going around the Earth. It was a circle going around the Earth with a circle on it. And so the planet was going around this circle as this whole circle was going around the sun. It was very complicated. But it worked. It worked to predict what was happening. Now these extra circles, don't write it down, I don't want you to know it. But if you're super interested, those are going to be called elliptocycles. And elliptocycles, here's what we end up with elliptocycles. Okay? We have the Earth, a planet on an elliptocycle. Excuse me, epicycle, not elliptocycle, epicycle. The planet's going on the epicycle as the epicycle is going around the planet. There's what it looks like. This was the first model of the solar system right here. And this model gets some things right. This model correctly says, okay, Mars is going to go like this across the sky. Right, so if you can see how it's, is this model correct or incorrect? This is not right, but it does predict what Mars is going to be doing in the sky. So, next. The next person we have, Copernicus, was born in about 1500. He came up with the sun-centered model of the solar system. So the solar system has the sun in the center. The Earth is going around it. Everything's going around the solar system. The moon. But his model was not accepted. His model didn't quite work as well as the epicycles. Those epicycles they had fine-tuned them for 1,300 years. They could get really good predictions with the epicycles here, whereas Copernicus, who was working with perfect circles, he would say, okay, I predict in 1 year Mars will be here. A year later, it would actually be here. And they say, oh, Copernicus, you're silly. Look at how wrong you are. But that was just because he was doing the wrong kind of math. He was doing mathematics with circles, and it took a really smart guy named Kepler to come along and start doing the math with ellipses. Those ellipses are what the real orbits look like. Well, anyway, Copernicus kind of gets put in the back burner. We forget about him a little bit. Brahe shows up. And Tycho Brahe, he agreed with one part of Copernicus that planets went around the sun, but get this, and this was a very accurate model, the sun orbits around the Earth, was the next model here. So, here's the Earth, the sun goes around it, but all these other planets somehow magically are going around the sun. And that's Brahe's model. Planets went around the sun, but the sun orbits the Earth. Okay. Have you guys heard of some of these people before? Have you guys heard of Copernicus before? Okay, I thought more of you would have heard of Copernicus. Well, I know a lot of you have heard of this last fellow, Galilei. Okay. He invented the telescope. He invented the telescope, and That's important. And one of the first discoveries he made with the telescope is that he discovered Jupiter's moons. So Jupiter has these moons going around it. And the fact that Jupiter, this star, it looks like, has moons going around it, means that this is evidence that moons and things can orbit something other than the Earth. Because up till this, we didn't have really good evidence that anything could orbit anything but the Earth. So he made observations that proved that the sun is the center of the solar system. So he made observations that proved the sun is the center of the solar system.